Thank you for coming. It's a weird feeling to be sitting while talking, so let's see what it does. So that title doesn't make any sense, right? We have 40 minutes for that to make sense, so bear with me, and it might make some sense at the end. It's not really a technical talk at all. Interestingly, it's almost the opposite talk from the keynote we just had from Brian Goetz. So we have some contrasting ideas. But it's mostly a talk about words, because I'm quite a lover of words. I love the way they interact with each other. I love tracking their lineage through various languages and through history. And we'll be spending a few minutes talking about words and how they interact with our way to program. So to start, we should ask ourselves a very simple question. What is the essence of our job as software developers or software computer science researchers? It's a really simple question, right? And it should have a very simple answer. So someone come to us with an idea of something that could be done with computers. We light up our very powerful brain. We feed it with some hot beverage. And in the end, we end up with, well, mostly bugs. So it's probably more complicated than that. So let's try again. So someone comes to us with an idea of something that could be done with computers. We write a bunch of text files in a programming language. We feed that text into some kind of build system, and we end up with a binary that is executable. Of course, because we are lazy, we reuse code that has been written by other developers before us, which comes from the network. And then we end up with our binary, and we ask the OS to make the CPU execute our code. And during that process, the CPU will talk to, say, database or other computers across the network, or even if we are still working in the 20th century, it will talk with printers. But more importantly, our CPU will talk with devices that a user can interact with. Because in the end, the whole purpose of that process of producing software is to bring value to users. And we hope that, in return, users will bring profit and revenue to us. So all in all, it's a quite complex process. If we were to completely understand it, we would need to talk about physics and electronics and computer language theory and mathematics and even sociology or psychology, because there are human interaction in that process. And so it's quite extremely complicated. And to cope with that tremendous amount of complexity, we use the only tool we have to cope with complexity, which is abstraction. Abstraction allows us to go from something that is complex into tinier bits that are more simple. And once we have abstracted away the useless details, we can work with our simpler abstractions. And then we compose back this abstraction to get back the original complexity. So abstraction is a tool to make the complex simpler. But in the meantime, new abstractions are often difficult to understand in the first place. And hopefully, we have another tool to help us understand new abstractions. And this tool, which is very often used, is metaphors. Metaphors work by collecting a system of analogies and mapping from something that is complex and abstract into something that is more concrete and more easy to understand. So for example, if I say, a high well blue like the sky, it's only an analogy because there is only one mapping. But if I had, and in these orbs twinkled 1,000 stars. So first, it's the proof that I should leave poetry to professionals. But then it becomes a metaphor because, you see, multiple analogies work together. So on a schematic representation of that metaphor, we should see that there are highs that has the color blue, and that contains twinkles on their surface. And on the other hand, we have the sky, which has also the color blue, and that contains stars. And the metaphor maps from the left to the right. And I don't know if you are familiar with functional programming, but this looks like a functor. And we should say that metaphors are like a functor from something that is abstract and complicated into something that is concrete and more simple. But it's a little bit far-fetched because we use the abstract notion of functor as a metaphor to the abstract notion of metaphor, and it's maybe too much. So let's take a more concrete example. When we learn to count and to do basic arithmetic, we all in that room have used a very pervasive metaphor, which is the fingers. We use the finger to learn to count 1, 2, 3, 4, 5. And raising one finger is adding 1, lowering one finger is subtracting 1. And thanks to that metaphor, we start to grasp the abstract notion of numbers. But of course, at some point, we have to unlearn to use our fingers to count, because you cannot do proper mathematics with your fingers. For example, you cannot do a multiplication or a division. So metaphors are like a gateway to new abstractions. It's just a way to get in, but at some point, you have to cut the rope and go straight into the right abstraction in order to completely understand it. And since we have a little time, we should note that digits, the word digits in English, is an analogy from the fingers. In Latin, digitas is the word for fingers. So somehow the English language recalls the fact that we used our fingers to count in the first place. And there is another little digression I like to make in that talk. This is the most hipster metaphor ever, because it's a metaphor from before the word even existed. Because this is I don't really know the word in English. It's an envelope. It comes from Mesopotamia, like 3,000 years before our era. So even before the Greek existed. So the metaphor word, which comes from the Greek, didn't exist. It was a system to do basic accounting and to to verify that the tax that were collected were correct in their amount. So people used to wrap a bunch of these little stones on the lower right, that were metaphor for numbers in cattle or grain or something like that you had to pay as taxes. And then they wrapped them into a ball of mud. And then they inscribed a seal to prove it was their envelope. And so these little balls were used as metaphor for the quantity of cattle or grain they were sending to the government. But the problem was that to count and to verify that the amounts were correct, you had to break these little balls of mud, this envelope, and to count, to get back the little stones, and to count and compare the numbers. And by the way, a little stone in Latin, it's said calculi, and this is where the word calculus comes from. And so at some point, they were quite bored in that process of breaking these envelopes and counting and so on. And so they started to make little marks on the envelope to denote the quantity of stones there were inside. And that's basically how humans invented writing. So that's quite interesting to see that this kind of metaphor for accounting occurred to provoke the invention of writing. So that was a little digression to lead us to understand how important metaphors are in the way we think. It's so important that some scientists, like George Lakoff, which is a linguist, is a student of Noam Chomsky, you've probably heard of, and he has this thesis that the whole process of thinking and speaking is completely metaphorical. We always do metaphors from processes that occur inside ourselves and inside our minds to explain and understand processes that occurs outside. It's a little controversial thesis, but even if we don't agree with that, we must agree that metaphors somehow shape the way we think and the way we understand our surrounding. So let's summarize a bit. We have abstraction that allows us to go from something which is complex and difficult into something that is simpler, but still difficult. And then we have metaphors that take something that is abstract and difficult into something that is more concrete and more easier to grasp. So, by the rules of composition, should we understand that we have find some kind of holy grail that takes things that are difficult and complex into things that are simple and easy? That should be cool, right? Actually, it isn't. Because there are quite a lot of problems with metaphors. Metaphors do not abide any laws, which means that from a metaphor you cannot extract new knowledge. It can help you understanding something that you don't know by connecting it with something you know, but you cannot use that connection to go further into the unknown. Also, metaphors that pertain to a specific cultural context. For example, if I say to you, monads are like burritos, but you know nothing about Mexican food, this metaphor is of no use to you. And actually, this metaphor is of no use to anybody, but that's another question. So metaphors are blocked into some cultural context, and you cannot share them with anybody, with everybody, sorry. And finally, metaphors, they tend to stick. you will easily become trapped into a metaphor because it makes something easy. So it's really tempting to get stuck in that metaphor and try to push it ever and ever forward and beyond the boundaries it should have had in the first place. And that's probably where my talk begins to diverge from the keynote of Brian, because there is one metaphor that I've stuck way too much in that industry, and it's the metaphor of the object. You probably have at least heard about this book. It's Design Patterns from the well-known Gang of Four. I have a series of concerns with that book, and these concerns start right on the cover. I like Escher and his drawing, so it's not a problem with the picture on the cover. I have nothing wrong with the authors, so it's not about them. It's in fact about the word design on the title. I don't think design should apply to software development. That's because I am quite biased. I'm French, so my brain works in French most of the time. And in French, we have a very precise definition to the word design. It denotes something that is meant to be as beautiful as useful. It's when you join beautiful and useful, this is design. Okay? It's in French, we don't use the word design to speak about the process of building stuff. It's a very, very concrete and precise meaning. So, for example, the chair on the right, that's right, yeah. Left? Oh, of course. The chair on the left is an instance of design, whereas the chair on the right isn't. Okay? And so when we we put too much emphasis on the notion of design in software, I feel that we put emphasis on the beauty of what we produce. And I don't think the beauty is a property of code. Code can have multiple properties that are desirable, like readability, maintainability, scalability, and so on, but not beauty. Beauty is not property of code. Usually when I say that, people try and start throwing stuff at me, but I think you are still digesting the meal, so it's okay. But that was only the problem I had on the cover of the book. When you look inside it, there are a lot of things that they call design patterns. I have listed them there. And all that I see is, well, metaphors. I have no idea by reading in the book how I should be able to compose this stuff, like what is a composite command mediator. I have no idea of that, because these are only metaphors to, help me understand what I should do with object-oriented programming. These are not abstractions. And moreover, in these metaphors, there are a lot of them that are drawn from the vocabulary of construction, right? Decorator, builder, bridge, and so on. And this adds to the fact that we take a lot and lots of metaphors from this vocabulary of construction. We have architects, we have plumbing and building blocks and software craftsmen and so on. And if you remember, I said before that the metaphor we use they have a tremendous impact of how we think about the world. And so this pervasive use of construction-related metaphors, they tend to provoke and create a certain mindset about developing software. And this mindset I call the carpenter mindset. In this mindset, we tend to be obsessed on building stuff, creating designs. We only focus on the creative part of our job, right? We create code. When we arrive on work on the morning, there is no code, and we create it, and we get back to home at night. But it's only a way to see it. And it's a way that has some negative impact. First, when you create something, you become attached to it. And so when the business comes and say, well, you know, you should put that button there and change completely the schema of the database and so on, you can become quite upset because you've worked hard on specification and you created a design and it's your design, and it's not cool when you have to change what you've created. There is also another aspect of the carpenter mindset which is uncool, which is that in French we have a saying that says that you can evaluate the skill of a craftsman just by looking at how he takes care of his tools. It's much shorter in French, but yeah, anyway. And so when you are in the carpenter mindset, you always tend to focus on tools. As an example, a few years back, I was in a team that was tasked to build an application that should connect people that needed some kind of service at home, like babysitting or building IKEA furniture or stuff like that, and connecting them to people who will be able to provide these services. And at that time, this kind of business was quite new, so it was completely unspecified. And so we took that absence of specification and we said to ourselves, well, we don't know right now how it will be represented in database, so we should use MongoDB. And so we went straight on MongoDB, and it was schemaless, so we were able to update the schema quite easily. And so we went all in MongoDB. And then the business started to evolve, and we had to add some kind of recommendation engine based on the time between a provider had received an offer and the time he had answered to that offer, and gamification and stuff like that. And so we had to add some kind of history into our documents in MongoDB, and it quickly became a pure nightmare. And so we went to a big phase of refactoring, and we basically rewrote the system in an event-sourced way, CQRS and so on. But it was a nightmare because we were completely committed to our tool, which was MongoDB in the first place, right? We should have maybe used another kind of approach to that problem. So to sum it up, the carpenter, he builds stuff and something fixes broken things, and you know, it's always that metaphor of carpentry, right? But remember, the metaphors we use and which in turn shape the way we think, they were only there in the first place to help us understand new abstractions. And this abstraction, this is the real thing that matters. Because these abstractions, and when I say abstraction, I speak about mathematical abstractions, right? They have a whole bunch of cool properties. They are universal, right? A functor is a functor for anybody on the planet. And probably, if we ever meet an alien intelligence, they probably have some kind of mathematics, and we might be able to share some abstractions. It's very unlikely they call them functor, but we can compare them. Abstractions are permanent. Once you've proven a theorem, it will not be unproved. There will not be a category theory version 2 that will make obsolete our functors and monads and applicatives and so on. And more importantly, abstractions are lawful. They come with a set of laws that help you detect this abstraction in the wild, and that tells you how you will be able to compose them or what you won't be able to compose, right? Given the laws of, say, a monoid, I can look into the specification of my business requirements and say, there is a monoid, there is a functor. I will be able to do stuff with that without having written a single line of code, right? And in contrast with the Carpenter mindset, when we focus on discovering abstractions, we end up with another mindset that I call the cartographer mindset. The cartographer considers that his primary task is to discover abstraction inside the business requirements. Okay, the ID the people came to us with. When we are carpenters, we are eager to completely decompose that problem into simpler abstractions that we will then be able to compose back, right? And if the business requirements change, it's okay. We just get out again and discover new abstractions. And that's perfectly fine, right? This kind of abstraction discovery process has a good tradition in the industry with the DDD method of developing software. DDD stands for domain-driven discovery, right? Because no, there is no design. Yeah, that people say it's design, but I prefer to say discovery. And there is this excellent book that should preferably replace the design pattern books, which is a book from Debasish Ghosh, which is in Scala. So if you are not inside the Scala community, you probably didn't heard about it. It's basically DDD with mathematical abstractions. It's really cool. And it's like the cartographer manifesto, even if cartographer is my word, so there will be no cartography in that book. But DDD, it's completely about finding abstraction inside the domain, the business domain, and trying to materialize this abstraction into code. And so we have both mindsets, the cartographer and the carpenter. And both are not completely antagonists. And actually, we can, in the same day, be a cartographer on the morning and then become a carpenter on the evening, right? It's not, I am a carpenter or I am a cartographer. It's like I use my carpenter skills or I use my cartographer skills. And actually, if we push that even further, we should say that both are like dual of one another, right? The carpenter, he projects order onto complexity, and the cartographer extracts abstraction from the same complexity, right? Okay. So if you've been following with me without throwing anything to me, you should recall that I said that metaphor, we should be wary of metaphor. We should be suspicious. And after all, cartographer and carpenter, this is completely metaphor, right? So maybe I've been fooling you from the beginning, right? Actually, abstractions are not the silver bullets, right? I don't know if you heard about Alfred Korzybski. He was a Polish scientist from the 20th century. But before he moved to the United States, he was actually an intelligence officer in the Russian army during the First World War. And someday he was with the troop and the officers, and they went on a path which was blocked at some point by a river. The map showed a river. And so the officers gathered into a tent and unfolded the map, and they were like in a meeting for a few hours, wondering if they should go south for like 20 kilometers and try to cross the river using the bridge, which probably had been destroyed by the enemy, or if they should go north like 30 kilometers and try to cross the river at a point where the water were more shallow. And so they were pondering that and discussing and so on. And at some point, Korzybski was like a bit fed up with that meeting, and so he took a horse and he went forward for the few kilometers that separated them from the place where the river should have been. And there was no river anymore, because it was the summer and the river had dried out. And so the legend says that at this moment he had this revelation that a map is not the territory, which we should understand as our abstraction. They never completely reflect the reality. So at some point, we cannot completely rely on abstraction. And so the cartographer cannot be the only way we look at our job. At some point, we have to make our abstraction concrete again, right? So even if these two mindsets are not antagonists, we are forced to use both at some point. And so, to conclude, when we tackle a new problem, we should first try to extract as most abstraction as we can from that problem. And only then, when we have extracted and used all the possible abstraction, we have to get our tools out and use our crafty skills to make these abstractions concrete. And so, if there is only one thing you take home from this talk, is always do cartography before you do any carpentry. That's it. Thank you. My name is Valentin.
Do you think these two abstractions that programming is about, or maybe like we have other metaphors, like carpenters and cartographers. I do not think it's all.
Probably not. Actually, I like these two because they are, you know, like dual of one another, but probably on another axis there are other metaphors. But that's not important because, you know, metaphors are trouble and should be, you know, wary of them.
I like the message, but your final point was a very mixed metaphor about doing cartography before carpentry. And I wonder if you might say it instead, I mean, either channeling causivity, you do the cartography before you start walking, or the carpentry side, you don't like the word design, but you do the technical design, you do the paperwork before you get to chisel out. There's another saying about measuring twice and cutting once. That you should take care to make sure that you've got the plan right before you start building things. Would that be a better way of presenting the metaphor?
Actually, probably. That's the problem when you work with metaphors. It's always like blurry and mixed. But the thing about Korzybski is that anyhow, your abstractions, they will never be good enough to completely represent reality. So, but yes, it was also a metaphorical sentence about cartography, so maybe the choice was not the best one. But you know, I like when things are like tied up and completely blurred. Thank you.
So if you have to choose like both parts of being a cartographer and being a carpenter, right, and it's a line, what would the point? In the middle or in the cartographer side?
I tend to be more on the side of the cartography, but you have to move on the line every day, and even within the day, you cannot be stuck on one point. You have to choose the right, you know, mindset, depending on how deep you are in the project. You know, in the beginning, you should try to find the abstractions, but at some point, you have to have like side effects. A good example will be, do you know about free monads? Yeah? So first, you are a cartographer, you write the algebra of your free monad. But at some point, you need to be a carpenter and write the interpreters, right? So you start trying to remain as pure and as abstract as possible, but you don't have the choice. At some point, you will need to be concrete. So you have to move back and forth between the two. But personally, I prefer the abstraction part.
Okay. Next question.
Thank you.